Today we're going to be drawing Lewis structures for our Chem 111 lab this week. On this page we are filling out page 148 from the lab manual, looking at the Lewis structures for CF4. Our octet number is the number of electrons that our atoms want. Most of our atoms are going to want 8, thus the name octet. Carbon wants 8. Fluorine wants 8, and we have 4 fluorines, so that gives us 32 plus the 8, so a total of 40 for our octet number. Now, there aren't enough electrons for each of them to have as many as they want, so they're going to be sharing electrons. Carbon brings with it 4 electrons. Fluorine, valence, has 7 electrons, and there's 4 of them, so that gives us 28 plus the 4 from carbon, so a total of 32 for our valence electrons. To figure out the number of electrons that will be bonding, we'll take the octet number, subtract from it the number of valence electrons. So that gives us a total of 8 electrons that have to be shared between the carbons and fluorines in order to draw our Lewis structure. Those 8 electrons will be divided up into bonds. Each bond contains 2 electrons, so we'll take 8 divided by 2, giving us 4 bonds. Our non-bonding electrons we figure out by taking the number of valence electrons and subtracting the number of bonding electrons. So we have 32 valence minus our 8 bonding electrons, giving us a total of 24 for non-bonding electrons. In our Lewis structure, every electron is paired up, so our non-bonding electrons will be paired together in lone pairs. We've got 24 non-bonding electrons divided by 2 gives us 12 lone pair. Our central atom is always going to be the least electronegative atom as long as it's not hydrogen. So fluorine is the most electronegative, so it's going to go around the outside of our carbon as our central atom. In order to figure out if we have an expanded octet, we have to look at the number of bonds we have. So we'll look at the number of bonds. We have 4 bonds in this, and carbon is going to have 4 fluorines attached to it. So because we have 4 bonds and 4 fluorines, they match up, so we will have it's a regular octet, so not expanded octet. So now we can draw our Lewis structure. Carbon goes in the center. We'll attach our 4 fluorines with a bond for each of the fluorines. So we've used up 2, 4, 6, 8 electrons already. So now we can put together our 24 non-bonding electrons into 12 lone pairs around these fluorines. Our carbon sees 2, 4, 6, 8, so its octet is already satisfied. Fluorine is only seeing 2 electrons at this point in time, so we want to put in the rest of our electrons around our fluorines. So that's 1 lone pair, 2, 3. So if we look at that, now this fluorine right here is seeing 2, 4, 6, 8 electrons, so its octet is satisfied. And we'll do the same for our other fluorines. So now we've used up 6 of our lone pairs. And now we've used up we've got 3 more lone pairs to go. So we've got, so now as we look at this fluorine is seeing 8, this fluorine is seeing 2, 4, 6, 8, this fluorine is seeing 2, 4, 6, 8, and this fluorine is seeing 2, 4, 6, 8 electrons. So all five of these atoms are seeing 8 electrons. All of them have a satisfied octet. So the last thing we want to do is make sure that we have used our 32 valence electrons that we started off with. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. We've used all 32 valence electrons, so this is an appropriate Lewis structure for CF4. All right, now we'll do the Lewis structure for CH2O. Carbon, again, only wants 8. Our hydrogen, if we look at the directions in our lab manual, hydrogen only wants 2. So each hydrogen wants to see 2 electrons. There's 2 of those, so that gives us 4 for hydrogen. And oxygen also wants to see 8. So we have 8 plus 4 plus 8, giving us a total of 20 for our octet number. Carbon, again, comes with 4 valence electrons. Hydrogen comes with 1 valence electron, and there's 2 of them, so that gives us 2 valence electrons there. Oxygen comes with 6 valence electrons, so we have 4 plus 2 plus 6, giving us a total of 12 for our valence electrons. So if we take our octet number minus our valence electrons, that'll give us our bonding electrons. So we've got 20 minus 12, giving us 8 bonding electrons. 8 bonding electrons, those go into pairs into bonds, so we'll have 4 bonds. And our non-bonding electrons is going to be the 12 valence that we started off with, subtracting the 8 that are in bonds, which will give us 4 non-bonding electrons. Again, our electrons stay in pairs, so when we look at our number of lone pairs, we'll take the 4 divided by 2, so that will give us 2 lone pairs. Of our choices here, hydrogen is going to be the least electronegative element, but it is never going to be at the center of a Lewis structure. So our next least electronegative is going to be our carbon. So that will be the one that the hydrogens and the oxygens attach to. We have 4 bonds, and we only need to attach 3 atoms to carbon with those 4 bonds. So we have a regular octet, so no expanded octet for this structure. So carbon is going to go in the center. Each hydrogen is going to be attached to the carbon. Again, hydrogen only wants to see 2 electrons, so we'll only ever draw structures where hydrogen has 1 bond connecting it to the other atom. Hydrogen will never have lone pairs around it. It will never have multiple bonds. And then we attach our oxygen. Now this only gives us 3 bonds, and we need to draw 4. So that puts us in a situation where we have to draw a multiple bond. The only one that can accept the multiple bond is going to be our oxygen. So we'll have a double bond between carbon and oxygen. Now we've got 2 lone pairs that we can add to our structure, so we need to look at the octet. Again, hydrogens are both satisfied with their 2 electrons that they're seeing in the bond. Carbon is seeing 2, 4, 6, 8, so its octet is satisfied. Oxygen is only seeing 2, 4, so the oxygen atom is going to be the one to take those 2 lone pairs. So now we've used up our 4 bonds and our 2 lone pairs. We'll do a quick count to make sure we've used all of our electrons. We've got 2, 4, 6, 8, 10, 12. We've used 12 electrons, and there are 12 electrons in our valence electrons, so this is a proper Lewis structure. Now we'll do the Lewis structure for AlBr3. Aluminum is one of our elements that can support an incomplete octet, so it is fine if it can see 6 electrons. Bromine wants to see 8, and we have 3 of those, so that gives us 24 plus 6, or 30 for our octet number. Aluminum is going to bring with it 3 valence electrons. Each bromine is going to bring with it 7 valence electrons, and again there's 3 of them, so that gives us 21 valence electrons from bromine for a total of 24 valence electrons to work with for our structure. Taking our octet number and subtracting our valence electrons, we get 6 for our bonding electrons. 6 divided by 2 gives us 3 bonds. Keeping in mind for later that we want to have at least as many bonds as we have as many atoms attached to our central atom. So we've got 3 bromines and 3 bonds, so it looks like we're in a situation where we'll have a regular octet. Our non-bonding electrons are going to be our 24 valence electrons, subtracting the 6 that were used up in bonds, so that gives us 18 for our non-bonding electrons. So we take our 18 divided by 2, giving us 9 lone pairs. Bromine is going to be the more electronegative than our aluminum, so that will go in the center. And as I said before, we had 3 atoms attached and 3 bonds, so we do not have an expanded octet. So we will draw our aluminum in the center, using our 3 bonds to attach our 3 bromines. And then we need to use our 9 lone pairs to complete the octets, remembering that aluminum only wants to see 6, so it sees 2, 4, 6 right now, so it's satisfied with its incomplete. So we will be putting our lone pairs around these bromines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've used my 18 non-bonding electrons in 9 lone pairs to satisfy the octet of each of these bromines. So each bromine is seeing 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So each bromine has satisfied its octet. And then we'll do our last count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's the number of valence electrons that we had to start off with. So we've satisfied this Lewis structure.